Okay, so today we're going to start with applications and linear functions. And what you need to do for this part of the packet, we're going to work in starting with page 87. So you have to keep in mind what is linear function here. So all these word problems we're going to solve, they have linear relations. So every time we have that, you need to think about the equation of line, which is mx plus b. So this is the formula you're going to use. And also, if they're talking about rate of change, probably they're talking about the slope. So every time we're talking about change in something, that's the slope. And you're using the slope formula, which is y2 minus y1 over x2 minus x1. So these are the things we're going to use in these applications. We're going to use all the formulas we have for equation of line or linear function. So I'm going to start with number 1. And then I'm going to do a few more, and then you can finish it in groups. So number 1, we have if 1 gallon of gas costs $2.50, how much it will cost to fill a 15-gallon tank? And you're going to solve this using proportion, using conversion, and linear function. And you have to explain why they all give the same answer. Okay, hopefully you're going to get the same answers, right? If you don't make mistakes, you should get the same answers. So using proportion, how are you going to use proportion? You're going to make ratio between two things, right? So here we're talking about the cost of gas, the money amount, and gallon. So 1 gallon, so I'm going to make proportion like this. 1 gallon, how much it is? $2.50. Equals, now I have to make sure I'm consistent with the units. If I put gallon in the top and the dollar amount in the bottom, I have to put it the same way in the other side of the equation. So how much it will cost to fill 15 gallons of tank? So 15 gallons is going to go in the top. And they're asking how much it's going to cost. So it's going to be X in the bottom. So this is my proportion I set up. And how you solve it? You cross multiply. You multiply the two numbers across. And you technically divide by the number across X. But in this case, it's 1. So just multiply those two. And it's going to give me the X. So X is going to be, when I multiply 250, and I'm using my calculator to check it out. So 250 times 15, that's 37.5. So it's going to be $37.50. Okay, everybody understanding this? Any questions how I set up the proportion? So get 37.50. Now, if you do the other methods, you should get the same, right? So this is the proportion. How you do the conversions? So you're doing conversions when you have gallon to dollars. So 1 gallon is $2.50, right? So if it's 15 gallons, you multiply. So you have 15, you multiply 15 times 15 gallon, you multiply by 250. This is the conversion over gallon, 1 gallon. You cancel the gallons and the answer is in dollars. So this is the conversion. Everybody understand that? So conversion is when you cancel the old unit, the new unit, remember? So that's what you're using. If you have something old unit, you multiply by the ratio between the old in the bottom and new in the top. That's the conversions. That's what you're doing with conversions. old unit cancel and you have left with the new one. The same way, gallon, you're changing gallon to dollar amount. So you cancel the gallons and you're left with $37.50 because you multiply 15 times 250. Okay? Then we're going to set up a linear equation. So how are we going to set up a linear equation? Here we can use, you can set up the function, and then we can, so the function here to calculate how much is going to cost you for X gallons, the function is going to be, each gallon is 250. So the function, I'm going to put the function of X is going to be 250 times X, because every gallon, X is the number of gallons, every gallon is going to cost 250. So when you multiply 250 times X, it's going to give you the, how much it's going to cost you, right? In this case, when you plug it in 15, so it's going to be F of 15, you plug it in, so it's going to be 250 times 15 is going to give you the same answer, right? So this is the functional notation using the linear equation. Okay, makes sense? Any questions on this one? So these are the 3 different ways to solve it. Now explain why they all give you the same answer. Because why they give you the same answer? Any ideas here? Why? Why do you think they give you the same answer? Because all these different approaches to change gallon to dollar amount using the same proportion, the same unit rate. When you do a proportion, you're also consistent with the units. And if you do linear function, you also set up the linear equation using the rate. The slope is 250. Okay? So all of those, they give you the same answer because you're doing correct for all of these different ways of solving. Okay, make sense? Okay, so now let's see which one you want me to do. So I'm going to do also, let's do, which one you want to do? Let's do number 3. Let's do number 3. I'm going to do 3. And probably I'm going to do 1 or 2 more, and then you can work in the rest of it. So all these questions, you just have to analyze them. Think about what's happened. You have to read them carefully. So number 3, it's Mr. Thompson, it's in a diet. The graph showed the weight over time. So you have the x-axis is months. So you have first month, second month, how much is his weight. And then the y-axis represents the weight in pounds. How much did he weigh when he started the diet? So looking at this, he started the diet at 0 months, right? So I need to go and check what is the number in that graph. What is the number there?
260.
60 pounds, that's right. Okay, so make sure when you have word problems, make sure you write down the units, they're important. So it's 260 pounds, he started the diet. Now, how much weight did he lose every month? So here you have to find the rate of change, right? So we can use, or you can do from month to month. So the first and the second, you can just take 2 points and then find the swap. That's how you can calculate it. So let's see, I'm gonna use the points. So I'm doing B. I'm gonna use when X is 0 months, he weighed 260, right? And when I'm gonna use another point. So let's say, let's pick this one. It's on the line, so that's why I'm picking this one. So it's 10. And what is the number here? 220, right? Okay, so we have these 2 points. We need to find the swap using the swap formula, and the swap is going to give me the rate of change, means how many pounds he's changing every month. So I'm going to do, we're using the swap formula y2 minus y1. And if you remember, we're going to name each number. So we have x1 is 0, y1 is 260, x2 is 10, y2 is 220. And then you're going to plug it into the formula. So we have what you have. Y2 minus y1, so it's going to be 220 minus 260 over x2 minus x1 minus 0. So when I simplify that, obviously I'm going to get negative number because the swap is negative because it's decreasing. The weight is going down. So when I subtract, what I get, 40, right? Negative 40 over 10. And when I divide those, I'm going to get negative 4. So the swap is 4. And they're asking how much weight he lost every month. He lost every month 4 pounds, right? Yes? Everybody understanding that?
Yes, ma'am.
Okay, and then you're going to go to next one, C. So I'm doing C. It says, estimate how long he has to be on a diet to weigh 189. So I need to look at the Y. When Y is 189? More people coming, okay. When it weighs 189? Now I have the swap. I don't see it in the graph, right? So it has to be somewhere after the 10 months, right? Because at 10 months, the weight is 220. So now what I have given, 180 is after the 10 months. What I have given, I have the swap. I have also the 260 is my y-intercept. So this is the B. So my equation, the equation of this problem, of this application is going to be y equals negative 4x plus 260. So this is going to be the equation. Why is this equation? Because the slope is negative 4. We just found that, right? And B is the y-intercept, means when x is 0, that's the y-intercept. And using this equation, I need to see when y is 0 or x is, I'm sorry, when y is 198 or x is 198. What do you think it is? The pounds is what, x or y? It's the y.
It's Y. Yeah.
Yes, the month is x, the pound is y. So this is x and this is y. The weight is y. So they give me 198 pounds. That means that's my y. So I'm going to put 198 here in the place of y. Negative 4x plus 260. And I need to find x. I need to find after how many months, right? So I'm going to solve this equation, and that's going to be the month when Mr. Thompson weighed 198 pounds. Okay, so how I'm solving this, I'm going to subtract 260 in both sides. And then I'm going to get, what is 260 negative 260? What do you get? Minus 198.
62, so negative 62.
Negative 62, that's right. Equals negative 4x. And then I have to divide both sides by 4. And or negative 4, sorry, negative 4. So what you get?
15.5.
15.5 months, right?
Mm-hmm.
Okay, everybody understanding this? Okay, any questions? Okay, so now let's see what else we can solve. We can solve, let's do one more, and then you can work on some of those. So what I skip number 2. Actually, number 2 we can discuss it, it's just discussion of this. And then I have number 4. We can talk about that. Number 5. Let's go ahead and do number 6. Let's do 6. Or which one you want to do? Pick one.
Six is cool.
Okay, let's do 6. So we're gonna have 6. So for number 6, we have what we have. The temperature is related to altitude, and this is the formula. So they give me the formula here, where h is the thousands of feet, that's the height, and T is the temperature in degree Fahrenheit. Okay, so this is degree Fahrenheit, and this is in thousands feet. Okay, identify and interpret the slope. So which number is the slope here? Which number is the slope? Remember, mx plus b, right? Here you don't have x, you have h, but still the number in front of the variable is the slope, right? So the slope is what number?
Negative 3.5.
Negative 3.5, that's right. What? Degree Fahrenheit, right? So negative 3.5, so what that means, the slope is increase or decrease? In this case is what? If it's negative?
Decrease.
Decrease. So how are you gonna interpret that? What that means if the slope is negative 3.5? What that means? The temperature, is it decrease or increase?
Decrease.
So the temperature, so how are you gonna explain that? So that means the temperature decrease by how much?
3.5 degrees.
Yes, by 3.5 degree Fahrenheit per what? What is the unit for the height? Per 1,000 of feet, right?
Yeah.
Okay. So everybody understand that? That's how you interpret that. The next one is what should be the temperature if the height is 12,000 feet. So that's the height, right? So when h is, what's gonna be h? If h is in
12,000.
What is gonna be h? H is gonna be 12 because h is in thousands. Okay, so that means when you have when you go to 12,000 feet in the formula, h is going to be 12. So what you need to do is just replace h with 12 and calculate the temperature. So we're going to plug it in. So the temperature of 12,000 feet, or just 12, in the formula is going to be negative 3.5 times 12 plus 58.6. So let's see what's going to be the temperature here. So we're going to simplify this. And let me know what you get. So I have 3.5 times 12. That's negative 42, right? And you're adding 58.6.
100.6.
It's a negative. No. It should be 16.6. See, this is
Oh, see.
negative here. So
Mm,
multiply those things a negative, and then when you add this positive, it's going to be 16.6. That's what I
that
get,
makes sense.
degree Fahrenheit. Okay?
Mhm.
Everybody get that? So that was the answer for B. So for these questions, you have to be careful what is given, X or Y, the height or the temperature. So you have two variables here. That's what you need to differentiate. If you have given the height, and also the unit is going to help you. The height is in 1,000 feet. Okay, the temperature is degree Fahrenheit. Okay, so that's also help you which one is X, which one is Y. In this case, it's T and H, but still the same idea, independent and dependent variable. Okay, and then let's do the last one. The last part here we have at what height would the temperature be 32 degree Fahrenheit? So what is 32 degree Fahrenheit? Is it X or Y? Is it the T or the H? T is the temperature, right? So T is going to be 32, and you technically have to solve this equation. So you have to solve 32 degree equals negative 3.5 H plus 58.6. So we need to solve this equation to find the height.
So since it's T, like in the formula, it says T and the H
Yes.
equals negative 3.5. So would we put 32H equals negative H?
What you guys think?
Since there's two variables in the equation, or no?
Now, T of H, this here of H means you have a function. So technically you don't put of H there. The value of T of H is 32. Okay, so you don't put T of H. You don't put of H.
We just leave it at 32.
Just leave it 32, yes.
Okay.
Okay. So now from here, we're gonna solve this equation. So we're gonna subtract 58.6 on both sides. And you're gonna get what you have, negative, what is that? 58
Negative 26.6.
minus 32, okay. 26.6
Mhm.
equals negative 3.5 H. And you're gonna divide both sides by negative 3.5. And you're gonna get positive 7.6, right?
Yes.
So the height is gonna be 7.6. But how many, what is the height actually? At how many feet?
Thousands of feet.
Okay, so it's gonna be 7,600 feet. So the answer here is gonna be 7,600 feet. Okay, because the answer, the height is in 1,000 feet. So when you have word problems like this, you just have to be careful. What is the unit, and the answer you get, you have to change it to whatever unit it is, okay? So that's the answer for C. We have the answer for B was 16.6 degree Fahrenheit. And then the answer for A was negative 3.5 degree Fahrenheit. That was the swap. And this is how you interpret it. The temperature decreased by 3.5 degree Fahrenheit per, oh, I put per 1,000 feet, okay? I was thinking about something else, I guess. Okay, So this is how you solve number 6. Any questions? Okay, so all of these questions you have, all of these word problems, we're going to go over everything in groups. You have to keep in mind the basics of linear function. You have a slope, which is the rate of change, increase or decrease. You have the y-intercept is the beginning point. And also keep in mind the units. Are they in thousands of feet or are they in something else? So you have to keep in mind that also, okay? So that's what you have for today. You just have to solve some word problems, okay?